Okay, this is exercise 10.1. I'm going to do some of the even numbered problems since the odd numbered problems were assigned for homework. The instructions for 10.1 say, which of the following deductive arguments are valid and which are invalid? Decide using the intuitive test for validity. If an argument is invalid, specify a counterexample that shows the argument is invalid. So this is review. You remember we did this early in the semester. We're reviewing deductive reasoning because we are soon going to move on to inductive reasoning. And you need to be reminded what deductive reasoning was as we move on to inductive reasoning. So this should be review. We talked a lot about the counterexample method back early in the semester and other ways of sort of determining whether an argument's valid or invalid. But remember the definition of valid, right? So an argument is valid if its premises guarantee the conclusion. If the premises were true, the conclusion would necessarily follow, right? So that means an argument is invalid if it's possible for the premises to be true and the conclusion to be false. So then the counterexample method is basically the idea, describe a situation in which the premises of the argument come out true and the conclusion comes out false. All right. So looking at number 2, no cat is a reptile, no reptile is a splurp. So no cat is a splurp. Now what is a splurp, you might be asking? Who knows, right? And this is one of the points we emphasized when we talked about validity, is that validity is about the form of the argument. It's not about the content. It's not about whether sentences actually are true. It's about whether it's possible for the premises to be true and the conclusion to be false. Now the word so is a conclusion indicator word. So this argument basically has two premises. No cat is a reptile. And second premise, no reptile is a splurp. And the conclusion then is no cat splurp. Okay, so the question then is it possible for this premise to come out true, this premise to come out true, and the conclusion to come out false? And again, we're talking about possibility here. We're not talking about whether it's actually true or actually false. We're saying, is it possible this could be true, this could be true, and this could be false? Now, sometimes when you have no, like the word no or the word any or the word all, a diagram can be useful. So I'm going to show you an example of my terrible artwork. So the first premise says no cat is a reptile. So that means if we drew a circle that encompassed all the cats, I'll put a C there for cat, and we drew a circle that encompassed all the reptiles, put an R there for reptile, there's no overlap at all between them, right? That's what it means, no cat is a reptile. So we can visually diagram premise 1 like this by drawing two circles that have no overlap, because that shows that there's nothing that's a cat that's also a reptile. No cats are reptiles. All right. So that's a representation of premise 1. Premise 2, no reptile is a splurp. So all that means is when we draw the circle for splurps, it just has to be completely separate from the circle for reptiles. So now imagine we draw it like this. And this is my circle of splurps. Right? So the way I've drawn it now, you'll notice, makes both premises true. No cat is a reptile, because here's a circle of cats and here's a circle of reptiles, and they're both separate from each other. There's no overlap. Second premise says no reptile is a splurp, right? That's true because, again, here's reptiles and here's splurps, and they're completely separate from each other. So the premises are both true. But you'll notice also the way I've drawn it, it's not the case that no cat is a splurp. In fact, the way I've drawn it, all cats are splurps. So that shows you it's possible to make both premises come out true and the conclusion come out false, right? And it's just that possibility that makes this an invalid argument. So we would write invalid. Okay. All right, now how do I quit drawing? Okay. So number 4, we'll go on to next. So number 4 says the U.S. House of Representatives has more members than there are calendar days in a leap year. Therefore, at least 2 members of the House must have the same birthday. All right. So this one has just one premise. Remember, the word therefore is a conclusion indicator word. So the premise is U.S. House of Representatives has more members than there are calendar days in a leap year. So it has more than 366 members. So a regular year has 365 days, and a leap year has 1 extra day, so 366. And the premise is just saying there are more members of the House of Reps than that. Conclusion: at least 2 members of the House have the same birthday. All right. So again, the question here is it possible for the premise to come out true and the conclusion to come out false? Well, for that to be the case, we'd have to somehow make it, figure out how 366 plus members of the House could none of them have the same birthday. So if we went, okay, let's start January 1st. The first member of the House has a birthday then. Then we go to January 2nd, January 3rd, January 4th, right, etc. So if we put a member of the House in each of these, right, and we go on to February 1st, February 1st, etc., right? So we put one member of the House's birthday in each of those, right? Eventually, we'll end up on 12/31, right? And at that point, we will have had 365 days, 366, it's a leap year, and that would be 366 birthdays, right? So if there were only exactly 366, then maybe they could each have a different birthday. But again, the premise says there's more than there are calendar days. So 367, right, has to go somewhere where there's already somebody with a birthday, right? So as soon as we go past 366, we have to repeat, right? There's no possible way that number 367 is not going to repeat, right? So in other words, it isn't possible to make the premise true and the conclusion false. So we say this is a valid argument. Impossible for the premise to be true and the conclusion to be false. Right? Sorry, I should say premise, and now it's going to screw up everything. All right, you get the idea, though. All right, so let's go to number 6. Every member of the Progressive Labor Party has studied the writings of Chairman Mao. Bob studied the writings of Chairman Mao, so Bob must be a member of the Progressive Labor Party. So again, the so there is a conclusion indicator. So the last sentence is conclusion, premise. Every member of PLP studied Mao. 2, Bob studied Mao. Conclusion, Bob must be a member of PLP. Right, so that's the argument. And the question of whether it's valid or invalid is the question of, is it possible these premises could come out true? And the conclusion could come out false. Right? So the way that could happen, right? Imagine, maybe we could do this with circles. So imagine we draw a circle of everybody who has read Mao, right? And inside of that circle, we draw another circle, and this circle is all members of the Progressive Labor Party. And then over here, outside of the PLP circle, but inside of the Mao circle, is Bob. Put him right there. So now look, the first premise, every member of PLP studied Mao. That's true because this circle of all the PLP is inside of the circle of people who have studied Mao. So check, first premise is true. Second premise, Bob studies Mao, right? Bob is inside of the circle where of everyone who studies Mao. So check, that's true. Is it true that Bob must be a member of the PLP? No, because he's inside of the circle of people who studied Mao, but he's outside of the circle of people who studied PLP. So it's possible then to make the premises true and the conclusion false. So that means that argument is invalid. Okay. Let's see if I can go. Okay, so these videos can only be 15 minutes, so I'm going to go, probably end up doing 2. I'll try to get 8 done quickly, though, before I stop. Monterey Pop Festival features some of the greatest bands of the 60s. The Beatles did not perform at Monterey, so the Beatles must not have been among the greatest bands of the 60s. Okay, so premise 1, Monterey Pop had some greatest bands of 60s. Beatles didn't perform at Monterey. Conclusion, Beatles not a great band of the 60s. All right. So okay, so again, the idea here is to show if it's invalid. You want to see if it's possible to make the premises come out true and the conclusion come out false. I've been using circles, but you can also do what's called a counterexample, where you actually describe a situation, not visually draw it, but you describe it. All right. So I'm about out of time, so I will do a counterexample for this problem in the next video.